Hello, everyone. Welcome to the last session in 2025 from the Business and Industrial at the Royal Statistical Society. We have two of our colleagues, Professor Neil Spencer from University of Hertfordshire and Damianos Michaelides from the Cyprus Institute of Neurology and Genetics and University of Cyprus. They will talk to us for about an hour. They will present the life cycle of an R package. This is all for me. Somebody sent a heart. Okay, take it away, Neil and Damianos.
Okay, thank you very much, Christina, for that. Yes, my name's Neil Spencer. I'm going to be talking to you about the creation part of the life cycle of an R package. I'll explain why that's the case. Let me get my... Here we go. Let's go back to August 2022. I was asked if I'd join as a co-author for a new edition of a book, Applies Nonparametric Statistical Methods. The previous edition had been in 2007, the fourth edition, Peter Sprent and Nigel Smeeton. Peter Sprent has unfortunately passed away, so Nigel was looking for a co-author to help him develop the fifth edition. And one of the suggestions I had was that it would be good to have an R package to accompany the new edition. So that previous edition talked about software in a variety of ways, including, some niche software for non-parametric analyses, others that were, had costly licenses and so on. And so I thought, well, we're now in sort of 2022, an R package would be the way to go. So having that unified approach, so all the examples and exercises in the book could be done using this package. And so that was the idea that I came up with, and Nigel was went along with that, as did the publishers. Why do that? Well, we could have used existing R functions rather than create a new package. There's lots of other packages out there that will do non-parametric statistics, but there's a risk there. If those other packages became out of date, weren't maintained properly, then they might not work, and we'd have produced a book where the examples and exercises don't work because of things outside our control, that essentially those packages not being updated. So that was the reason why to create a special package for the new edition of the book. Did I have experience of doing this, though? No. That was the one downside of all this, a kind of idea of mine. On the other hand, though, I knew I could write R functions. I'm used to using R. I know that I could cope. I could make it get onto CRAN. I knew there were various ways it had to be done in order to be acceptable to CRAN. But there was a fallback position. If I couldn't get it onto CRAN, then I know I could provide the functions, and through the publisher's website, we'd be able to get those R functions to people, even if it wasn't going to be on CRAN. So that was my kind of the fallback position, that I thought, well, let's have a go at doing this. And so then I went up and said, okay, how can we do this? And I very quickly came across this Hadley Wickham and Jennifer Bryan's R packages, how to do this, essentially. An online book, essentially. And so in some ways, you'd have thought that, okay, does this make things easy? Well, no, unfortunately, it didn't make it easy, but it did give useful guidance. This was the book, the resource that I was using most as I was going through my creation of this and learning quite a lot along the way, which is why I'm talking about it today. One of the things I learned about was it was going to be useful to connect with GitHub, use RStudio, which is going to integrate with that. So that's all well and good. It'd be a good thing to do. So that meant I had to do some learning. I'd used a bit of GitHub before, but I had to learn how to use it properly, or at least in part use it properly, as opposed to use it in a kind of it does what I wanted to do. Similarly with RStudio, to be honest as well, I'd used RStudio extensively, but to use it a bit more properly, including using project rather than just writing individual function files, was something that I had to learn how to do for that. Another piece of learning that was required was to figure out how CRAN uses version numbers, which was a bit of and I'm being honest with you all, I still don't really understand it, but nevertheless, I've done it sufficiently that CRAN are happy with what I'm doing, which I think is a kind of a message that will come out of what I'm talking about. It's about doing things sufficiently for CRAN and understanding enough, rather than having to be an expert on everything. So when I was going to make this approach then, well, R relies on using a number of packages. Really, the whole idea is that it encourages you, even when you're writing a package, to import other packages, use other packages. The code's already written. Why write it all from scratch yourself? And of course, that's a useful thing. But it again raises this question: what happens then if the other packages break? If changes are made to R and another package is broken and something doesn't get updated, what's going to happen then? So what I decided is I'm not going to rely on other packages apart from a small number that are maintained by that R core team, the base, stats and utils packages that I'm assuming I can be fairly safe in assuming are going to remain compatible with whatever I'm going to be writing. They would make sure that any work on those wouldn't break my package. On the other hand, though, that meant I'm not using an awful lot out there, which is quite useful, and I had to accept that's going to require me to write code to do some boring manipulations and loops and stuff like that would be very easy in a one-line code if I was importing another package. But if I'm not going to do that, I've got to do that programming myself. I'm also, and you may find this a slightly odd thing, I'm also having to accept that my code's not going to be that good. My code's not going to be optimal, and it's going to be slower than other packages because I am not an expert on all things R and all things computer science from that point of view. But to me, that was acceptable. I'm writing a package here so that people can go through a book, do the exercises, do the examples, maybe use the functions outside in their own work as well. But I'm not trying to claim to be an expert and produce the most optimal package for non-parametric data analysis. So I was happy that, okay, if my coding's not optimal, that's fine. I also had to work out how much I was prepared to learn. You can integrate C++ code into our functions. As you can see there, I decided not to. That's something that would have been a bit of learning that was beyond what I needed to do to accomplish the task, and also something which, whilst it would have been interesting and good for me, wasn't something that I had the time to do. We'll find later on Damianos will talk to you. I know he has incorporated these things, and it's a great thing to be able to do if you've got that knowledge. Other things I could perhaps have done in parallel processing, I'm not going to get into that in this. It would have sped things up, obviously, but I'm leaving that. Other people can worry about that. Even some more, but might be more basic things about our S3 and S4 classes. If you've not heard of these, and I don't think, worry about these things. But these are sort of some of the objects in R can be these different classes, and I tried to understand it and didn't get very far, and thought, well, I know enough about them to realise I don't need to know enough in order to get this package going. So that's fine as well. I decided not to get into that. Optimizing memory storage. Well, again, there's issues there about, if I'm trying to do exact calculations, sometimes we can do enormous storage capabilities are needed, but on the other hand, we can use some simulation if exact calculations are complex, and there are other packages out there if people want to be able to use those and to do things in a more efficient manner. That was the kind of idea. So those are the kind of things I decided not to go down the route of. And again, the message there is you don't have to be an expert in everything in order to be able to write a package and get it onto CRAN. Some of the other things to think about was something to do with consistency. I've got a whole load of functions I'm writing, and what am I going to write though? What are the names of these functions? Am I going to, have words joined up with dots or underscores, or that camel case where the capital letter starts indicates a kind of a new word in the function name? I'd done a bit of the writing already, and then I discovered that the recommendation is to use underscores, but I'd already used dots, and there didn't seem to be there wasn't a prohibition for using dots, so I thought, well, I'm just going to stick to what I've done already. If I was starting again, I might use underscores for everything, but the dots are fine. So that was one decision I made along the way. and try to be consistent with that through all the functions I'm writing for my own sake as well as for the neatness of the package. Did I want to use capital letters when functions are named after people? When I'm doing sort of Wilcoxon tests or Fisher's exact tests and things so on like that, do I want a capital letter for them? Hummed and hawed about this for a while and decided to go with all lowercase. That was just for consistency from my point of view. I don't think CRAN would be upset if necessarily if I'd mixed it all up, but at the same time, it's nice to have a bit of consistency. Naming functions that do similar things to R functions. For a good example of that is this chi-square test function in R. The chi-sq.test function is in there already. I think it's in the base or the stats library. And I was going to be using that essentially, but I wanted to actually get the output, more detail in that. So I simply decided, okay, how am I going to differentiate my function from the existing R function name? And so I just added .ansm on the ANSM for Applied Nonparametric Statistical Methods, the title of the book. And so that was the purpose of doing that. So these kind of consistency aims, decisions I was making along the way, and I'm certainly not claiming those are the best decisions necessarily, but they're ones that worked for me at least, and were acceptable from the CRAN point of view. So I'm doing all this, and so all these decisions are being made at a relatively early stage in the process, and so I'm getting confident. Then, yes, I can do this. I can create this code, so hurrah! That's the minimum done. At least, even if I can't get it onto CRAN, at least I can create code in some kind of coherent way, and we can get that out there on the publisher's website at the very least, so that people can download the functions. But that's great. Okay, but that wasn't really the sole aim. That was a fallback position. What I wanted to do was to get it together for CRAN, and this was what I wasn't sure about. I knew there were hurdles to overcome, but it would be nice if the package, which I was calling it ANSM5, Applied Non-Parametric Statistical Methods, 5th edition, can I get it alongside other packages? That was my goal in all this. So I can write the functions, I can get them to do the right things. What other things do I need in order to get this onto CRAN itself? Well, one of the things is about testing when it comes to things. CRAN, quite reasonably, insists that you provide a suite of tests that show that your functions, your code is going to produce the results you expect, which is fair enough. Now, that's understandable they want this, but okay, I'm producing quite flexible functions. These are not just very small functions. These are, excuse me, doing various. I'm trying to do exact test versions of tests, asymptotic versions, Monte Carlo versions, all of the same tests, various specifications allowed. Some, different calculations are needed if ranks are tied in the data in the non-parametric tests and so on. So there was a whole range of various combinations of things that these could be an enormous suite of tests for just one function. And as I'll show you in a moment, I did quite a lot of functions involved. So this felt like a fairly onerous task. But then I was thinking, well, from a practical point of view, with so many possible combinations, we can't be testing everything. I think Damianos is going to mention later again some issues he found with this. And any moderately complex package is bound to have some edge cases that aren't tested rather as a result of this. So that's fair enough, I thought. And then I also thought, oh, hang on a moment. In the book, at the end of each chapter, we've got a set of exercises. Well, why don't I show those to be the tests? I'm creating the code anyway to actually run these exercises and provide solutions. Why don't we use those as the tests to be used for the package? So what's something that started off I thought was a fairly onerous task ended up, because I'm doing this for book purposes and we're creating examples anyway, those were going to be my tests. So that was a fairly useful thing to discover. So that seems fine. I'm using my laptop to create all this. I get the correct results on my laptop. And hurrah, we finished, have we? No, because it's not just getting the correct results on my laptop. They have to be done on the remote CRAN computers as well. They have to come up with the correct answers as well. And again, for reasons that are beyond my understanding from a computer science point of view, of course, computers don't always give exactly the same answers. There are issues to do with floating point rounding, which are, as I say here, too long and boring to go into, very frustrating. There are instances when my laptop was giving, nice, accurate answers, and the CRAN ones were, well, they weren't. And it was, well, what's going on here? They were over-rounding things as far as I was concerned. But anyway, had to get into sorting all that out, which on occasions was improving my coding, but on times it was just saying, okay, we can't deal with that many decimal places, because although my laptop will give that consistently, some of the computers that the CRAN are using won't. Fair enough. There was also the issue about some of the tests took too long. I mean, understandably, CRAN don't want their computers, sort of occupied doing tons and tons of tests for various packages, so there are some time limits involved. And in particular, the Monte Carlo testing had to be removed, essentially, because they just took too long to do a sensible number of Monte Carlo tests with so many functions and so many simulations. That was too long. So, okay, I removed those from the official testing to go into CRAN, but I could still do them myself on my own laptop to make sure that the functions were running as I expected. So that was okay. So I've written all the functions. Excuse me. I've written the functions. I've managed to sort out all the testing. So submitting it, have I succeeded? Well, there's it. I'm not expecting necessarily to read that, but that is the CRAN web page. So the answer is yes, I succeeded from that point of view. There were some bits that were more complicated than expected, as you might be able to see there. This is version 1.1.1, so I've had to do a little bit of maintenance on the starting off with 1.0.0, and Damianos will tell us more about those kind of ideas. I thought I'd finish off, though, by just saying some bits that are harder than expected. And one of them is simply my own fault for starting the task in the first place. I've got 58 functions I've written in this package. The book has a whole load of of tests and so on. So that's my fault for starting the task. And that's why it was harder than expected, because there was simply a lot to get done. Another thing that was more effort than expected, and again, you might not be able to see the bit at the bottom there, was as well as actually writing the functions, you've got to document the functions, and you do that in a way that there's headings at the beginning of the function which explain all the bits that are being used and so on, and examples, and there's a whole load of things. There's guidance to help you. There's even packages that help you produce these, but it was a bit of a slog going through all these different functions and making sure they were all up to date and correct. And those are the bits in the green at the top there, if you can't quite read the bits at the bottom, and the actual function itself only starts in the last couple of lines on that screenshot there. So those were something that was a bit of a pain. On the other hand, things that were easier than expected. Well, the PDF manual, which I thought, oh gosh, I have to produce that as well. No. If you get all those function headers, the headings right in those functions, the PDF manual is written automatically. So that was very much a positive discovery from my point of view. So that was a nice thing to discover. RStudio being part of the creation system, I was already familiar with using it, although I had to learn how to use it better. But having that familiarity already meant that I was a long way down the line to actually using it. And the other thing that was a bit of a surprise to me is that, well, writing perfect code, it doesn't have to be beautiful. My code is most definitely not beautiful. It's not perfectly commented. It's not efficient. It's not optimal. There's all sorts of things in which ways it could be improved. But it doesn't have to be that brilliant. It just has to work reliably for it to be acceptable on CRAN. And so that's the bit that was kind of easier than expected. I was half anticipating having to sort of change my the way I've been doing things in the past and improve my programming technique, but I got away with not having to do that too much. Finally, really, can anyone do it? Well, you don't have to be a computer scientist to do this. My knowledge is sufficient, but clearly limited. I was showing you all the different things that I couldn't get do earlier, integrating C++, parallel processing, S3, S4 classes, optimizing memory storage, all those things I could leave to one side and still succeed with this. Obviously, the more computing knowledge you have, the better, but you don't have to, be an expert in these areas to do this. Something that would be AI would make this job easier now. I mean, I should have perhaps have been more aware of the abilities of AI to write my code over the years since August 2022 when I've been writing this code. I was, a lot of Googling trying to figure out how I would try to get it to do what I want it to do. These days, of course, using an AI assistant to help with the writing that code would be a lot simpler. And it probably, I haven't tried it out, but it probably also, that generation of the function headers, the bit I was moaning about earlier, it probably make that simpler too. So it's probably going to be an easier job with AI now than I made it before. Would I do it again? Well, if I was sufficiently motivated, yeah, I wouldn't rule it out. It's an itch that has been scratched from that point of view that I'm now very pleased. It's a sense of satisfaction having got a package on CRAN. So I'm not desperate to do another one. The motivation isn't quite the same, but I know how to do it now. I know it's possible, essentially. And so that's all about the creation of it. Thank you for that. I apologise on the right-hand side for the blatant advertising of the book. But that's what if it wasn't for the book, I wouldn't be talking about this. And I'm happy to take questions now or later. Christina, I don't know which way around you want to do that.
I'm sorry.
I was just saying, do we want to do questions now, or do we want to save it until after Damianos has spoken as well?
It's up to people. If people want, somebody. Eli just raised his hand. Maybe we can take a couple of questions now quickly, and then more detail at the end. Eli, you're.
Yeah, are you intending to maintain the package going forward? There was new versions, or as people start using it, they come back.
Yes, I mean, open source. Absolutely, yes. I will be maintaining it. I did have some. Okay, I've only had one person contact me so far with spotting a problem with it, and bizarrely that was it was published on CRAN, but it wasn't being widely advertised because it was actually before the book had been published. But they'd obviously discovered it on CRAN and was using it and discovered some sort of a edge case that I needed to correct. So I was able to do that. And yes, absolutely, the intention is to carry on maintaining it. Who knows if there'll be a 6th edition of the book in years to come. But from the point of view of actually simply maintaining it so that it keeps up to date with any changes to R and any issues that are discovered in it, where if I'm using the functions myself, or other people spot them and let me know about them, then that'd be the idea.
Yeah, around the same time I didn't. He was talking about, were you there when he was advertising? No, I've just done my PVR. So
I'm not sure. I don't think that was a question.
No, it didn't sound like it.
Anyone else got anything to ask? Oh, there's a question actually Miller's asked in would I consider an equivalent Python package? From the principle, I could have considered a Python package. From a practical point of view, my R programming is an awful lot better than my Python programming. So from that point of view, it was going to be R. because I wouldn't have considered trying to put a Python package together just because I'm just not as experienced with the language.
Hello, thanks Neil. Thanks for the very interesting introduction to our packages and how to create them. So can you just confirm that everyone can see my screen?
Yes,
Yep.
can.
Yeah, okay, thank you very much. And many thanks to Christina for organizing the event and the business and industrial section. It's great to present today, and it's actually the first time that I am presenting something that's related to creating and maintaining our packages. So that's very exciting. Okay, so I'll start very briefly as Neil do. How do I got into R packages? So I started my PhD in statistics back in 2018, and very quickly a significant proportion of my life was shared with R scripts. So I had to build functions, and they had to be computationally efficient for my personal use, so that I can finish executing tasks quickly and computationally intensive calculation. So for that reason, seamless integration with C++ quickly became a must. Now, even though everything that I was creating was for my personal use, just for my PhD development, the first experience with CRAN came as a co-author in an existing package. It was called ASpace. So through the PhD, I completed like a side project. It was making a background algorithm that was running at the back of ASpace. It was becoming faster, and this was enough to get me as a co-author. So I joined this package as a co-author. Now, something that I was thinking while I was doing the PhD, and I still believe it in my research experience, I think that even though papers and books are clearly written and professionally explained, if you have to deal with complicated methods, if you have to implement them, in practice and code them, it's not straightforward, and sometimes it can take lots of time to implement those in R or any other package. So this idea led me to spend an entire chapter of my thesis developing the methods I went through as an R package. I call it F-design. So I thought that creating an R package will give more visibility to the method and create a more user-friendly experience to the readers of the methods. So after that, I continue doing the same thing. So every time I create functions and implementations that I believe there is potential use by others, I always think in terms of getting it onto CRAN, and this thinking led to another 2 packages from my experience in GSK and currently in my postdoctoral fellowship. Now, as Neil started going through the creation of our packages and getting them to CRAN, it's also very important to be able to maintain the packages on CRAN. So the way I see the creation is a very important milestone, but it's a short-term one, because you will work full speed to build the package, get it on CRAN, but you also need to maintain it. So maintenance, it's the part that will keep your package alive. So being on CRAN live at the moment does not guarantee be live on CRAN in the near or long-term future. So long-term maintenance of a package on CRAN is an ongoing deliverable. So when you build it, you create it, you get it on CRAN, you go back to 0 kilometers per hour, you can have some rest, but every now and then you need to increase your speed, get to 100 kilograms speed, maintain it, solve any issues, and then you can again relax and do it again. So it's an ongoing process that keeps on developing. Now, what's maintenance? So why do I need to do maintenance? I get the package on CRAN, everything worked. Why do we have to maintain it? Maintenance is all about ensuring that the package is functional in the long term. So as well as we do the CRAN checks when we create and get it for the first time on CRAN, we get some errors, warnings, and notes when we perform the CRAN checks. So errors are things that must be fixed 100%. We need to deal with them. Otherwise, the package cannot get on CRAN. And in the future, if errors occur, the package cannot remain on CRAN. Other than errors, when we do the CRAN checks, we might get some warnings. These are less strict than errors, but again, they are strongly discouraged, and usually they can trigger CRAN rejections. And finally, we have the notes appearing in CRAN checks. These are mostly informational, so there is nothing to be done by the user most of the times. You can deal with them, but it's really up to the user, and sometimes they might need to be justified though. Now, what do we mean by error? So a few words about error warnings and notes. So errors, for example, can be one error I came across in a few weeks back in the Hasse diagrams package. You may use a font family in a plotting graphic device that is not available. So when you have it in your examples of your functions, this will throw an error. So CRAN check will fail, saying that you have an error in your examples. Or as Neil said beforehand, packages, it's good to have some testing the edge scenarios of your workflow. So if there is a test failure, you might get an error saying that your execution is halted. Or if you have a dependency on your package and it becomes unavailable at some point in the future, then when you rerun your CRAN checks, you will get an error saying that your dependency package is not available anymore. So you have to deal with that. Otherwise, your package cannot stay on CRAN. Warnings are less strict than the errors, so it can be in the documentation of your functions. You might have an argument that is not included in the documentation, so the usage of the function might have a different length of arguments compared to the documentation, so you get this kind of warnings. Or a very common one is functions being deprecated, like the second warning on screen. So imagine having a dependency on your package, so you are using external functions from other libraries. What this warning says, it says that the function you are using from a dependency package at the moment is fine, but in the short term, this function is expected to change. It can maybe be archived, or it can maybe change name or arguments or usage. So you have to deal with that before actually the change applies. So warnings are less strict than errors, but we still need to consider them very seriously. And finally, we have notes that they are not of huge importance. They are informational, but it's good to deal with them before they might become warnings. So it might be a misspelling in the description, for example, or things are taking long to rebuild, like vignettes, or the example section of your functions might be computationally intensive, and you don't want that user experience from your potential users. So you might consider lowering down the computational intents of your examples, for instance. So let's say we perform the CRAN checks. When we create our package, we get it on CRAN. Why do we have to think about the errors, warnings, and notes in the future if at the moment everything is working fine? So what are the reasons that maintenance is needed? First and foremost, the most common reason for maintenance is that we have to adapt to new R versions. So R up versions quite frequently. So we have major releases, and this can break the behavior of our functions, or even the R-Devel, that's the development version of the next release. So when R prepares an app version that's currently under development, when we perform the CRAN checks for our own packages, CRAN tests against the R-Devel also, and not just on the current version. So especially when we have our app versionings, graphical devices, so how plots are rendering across devices, can break sometimes, or we might have some unexpected behavior for the S3, S4 methods, which are the object systems, or quite frequently C++ APIs like the RCPP package might have unexpected behavior when we are up versioning R. Now, second reason, we have to adapt to changes in dependencies. As Neil said, it's very important to keep light on dependencies, or if possible, avoid any dependencies at all. But this is not possible most of the times. You might end up needing to have a large number of functions, or very complicated functions. So quite usually maintainers rely on some dependencies. It's good to keep light on dependencies, but sometimes we have a few packages that our own package depends on. So within those dependencies, we cannot control their behavior. So the maintainers of those packages can make functions get deprecated, or they might consider removing some of the functionality of their packages. They might consider changing argument names, or make implementation changes. And essentially, since our packages are depend on those changes, then we might get some unexpected behavior. And something that does not happen regularly, especially if you use known packages and famous packages. But if you use packages that are not such famous and maintained regularly, some may go archived, so you might lose all their functionality immediately. Third point, we have to adapt to evolving CRAN policies. So the CRAN standards are strict. They have standards for documentation, code structure, their examples, and so on, their tests, for instance. So passing the CRAN standards at the moment and manage to get the package on CRAN, it does not mean that we can pass the CRAN standards in the future, so things can become more strict. So we might need to reconsider the standards, keep the package maintained, make sure that we can pass the CRAN checks before we receive an unexpected email saying that we have an issue with our package. Final point, it's quite funny how users of the package can discover potential bugs and report it back to us. So sometimes we get some emails from users saying that, why do I get this error? And after some time considering it, you discover that there is a bug in the package. So even if we are testing edge cases that appear in our own workflows, users can find something unexpected that we did not come across and report it back to us. So it's important to maintain the package in order to solve any unexpected behavior, any bug of the package. So we have all those reasons that we need to perform maintenance. It's a part of the process and we need to deal with it, but we have some practical suggestions, some procedures we can follow so that maintaining the package is more straightforward and less time consuming. So one of the recommendations is to run the RCMD check regularly. So that's the check that lets us know if there are any errors, warnings, and notes. So we can run those regularly. Even though the package is successfully on CRAN, we can run the checks at the back on our local laptop in order to make sure that the package still is compliant with the R standards. Something that I did not use myself in the past, but I came across a few weeks back, and I plan to use it in the near future. There is another command, the RCMD check as CRAN. So I'm not talking from personal experience, so a disclaimer here, but as I've read, my information is that this as CRAN addition to the check makes additional checks that CRAN does when checking the package before going live. So regular checks is a very practical thing to do. Second thing is to monitor the dependencies. So we have some dependencies in the package. It's good to pay attention, read the news that CRAN makes public when the app version are, and keep an eye on any major version releases of the packages we depend on. So if we notice that a big change is coming to the R level, so the version that is currently under development, it might be a good idea to make proactive steps in order not to see any unexpected behavior from the packages that we depend on. Third thing is that we can use tests. So as Neil said, the tests are there to test the extreme cases. So if anything on our dependencies change or the app version of R is affecting us, we can rerun the tests and make sure that no wrong results are produced. So we need to keep an eye on the edge scenarios and make sure that the package is still reliable, producing the right results, the results that we expect to get. The examples in the functions don't always catch this, but the tests which are more of edge scenarios can catch those errors. Finally, I have the GitHub actions, which I believe for maintaining a package is right at the top of importance. So I have it as a separate slide with a bit more of detail. So GitHub, it's important in the sense that we do not want to break the functionality of the package that is already on CRAN. So that's the first thing. So everything we do maintaining the package, we want to keep it in a separate version, let's say a development version, keep it separate from the main branch so that we do not break the functionality of the main branch. Second bit is that we might have collaborators. So maintaining the package might need to go across the collaborators for review, comments, and approval. So GitHub Actions can help in all these scenarios. So GitHub provides two very important actions, the push to GitHub and the open a pull request. So the push is uploading local changes to your GitHub repository. So let's say you have your package, you can create a GitHub repository with the R files, your documentations, and so on, everything that makes up the package. Then when you maintain it, you can make the local changes to your functions, and you can use the push functionality to push all the changes to the GitHub repository, and immediately when you perform the push, GitHub will do the RCMD check automatically, and that will be checked against all the operating systems. So if you use a Windows local computer and you do the local checks, it might not get an error that can come up from a Mac OS device. So when you push the changes to GitHub, the check will be performed across all platforms, and it will run all the dependency checks. So you are safer by pushing stuff to GitHub. The second thing is the pull request. So as I said, it's good to keep a separate development version rather than making the changes to your main branch. So at the point when you have the development, you can pass it into your collaborations, your colleagues. They can review, comment, and once your development version is ready to go, it gets no errors from the checks, then you can create a pull request and release the development to your main branch. And that's after you are making 100% certain that no errors will suffice in the main branch. So GitHub Actions can make the entire process more effective and less risky. Now, a few final notes for planning ahead. It's to understand our dependencies. So we are using them dependencies, even though it's good to avoid them. We are using them, they are saving us time, and they are leading to computational efficiency because experts of a field created those packages. But it's good to know and understand the dependencies. So if they get archived or they break in the future, we can react and maybe write internal functions on our own package and save the game. So if we are totally unaware of how the dependencies work and what they perform, then we might find it difficult to adapt to unexpected behavior. Second thing to do is to keep an eye on how often those dependencies upversion. So if we are using, let's say, a dependency on, I don't know, the ACE-based package, and myself and my colleagues are not upversioning the package for a year or for 2 years, then that's an indication that things may go bad. This package might end up archived or might end up throwing errors. So it's good to see that the packages we depend on are upversioned and they are maintained regularly. Finally, something that I do in the hazard diagrams package. In the examples, I'm using some data from the DAE package, a very successful and used by many users package. So I consider it a safe package, but still those data sets are public. They are on CRAN, so they are available to all the users. So we can keep some local copies of functions or data sets. So in case something goes bad, they are not maintained or they may delete it from those packages, then we can create our own local functions, local copies, and update our package with this information. So it gives us some sort of less risk by keeping some functions that we depend on or some data sets that we depend on locally stored on our machines. So I will stop here. So we went through how to maintain long-term our packages, a few maintenance practical considerations on catching future breakages. It's good not to depend on fragile dependencies, and if we do depend on them, it's good to know how they work, and that will give us some sort of indication that we can save things if the dependencies go wrong. And finally, GitHub Actions in terms of maintenance, it's very important, although it's not of great importance when we are developing the package for the first time, getting it to CRAN. GitHub can save lots of time in terms of maintenance. So I'll stop here. Great thanks to the organizers for today, the BIS and the Royal Statistical Society in general, and happy to answer any questions if there are any.
I've got a question. As you're working with GitHub, which I like very much, do you know how many people have actually been using your package?
So there is some information online from CRAN, how many downloads your package receive from CRAN, but you can get sort of an indication how many people are downloading from the GitHub repository. In my own packages, it seems that most of the downloads come from CRAN rather than from the GitHub repository.
And are you intending to open it up in GitHub for crowdsourcing?
I did not consider that. Yeah,
because I've been following a different team that is partially Microsoft, partially Amazon that doing and actually contributed to the package. They started and now moved to Python called DY. It's a very interesting experience and very enriching, actually. It's unbelievable what people are willing to share, and then when you've got people getting together, what do you get out of it?
Absolutely, yeah. It's something that I can keep an eye on and have a look, maybe.
And I'll just mention, because I'm kind of plugged into GitHub, they are about to release a lot of generative AI capabilities that help developers. So when you do a pull request into GitHub, it will do some scanning for security scanning, so you don't have any security issues in your code, that you're not using packages that are bringing what's called supply chain attacks, and do some evaluation of the quality of your code, and do recommend use kind of what's called pull request review for you automatically, which is unbelievable.
Yes, I mean, a question about Andrea asking about how long do creating the packages take? It's rather hard from my point of view to actually say that, because at the same time as creating the actual code, I was with Nigel, Smeeton, we were rewriting the chapters of the book as well. So it was kind of something that was done at the same time. August 2022 was the first conversations had about the book, and the package was online 2 years later. That's not 2 years of full-time work by a long shot. Although it's difficult to actually put a figure on that from my point of view.
Yeah, I totally agree with Neil. So from the 3 packages I have, like the one I was developing through the PhD, I was working full time on it. It was just making up of 3 live functions. It had many functions at the back that we are not available to the user. It was internal functions, but because I was working on it full time, and I had the R experience and the C++ experience by that time, it was like less than a month getting into CRAN, but like the one that I am developing now, it's the 4th month that I'm working on it, because we are doing some side work also, and it has more functionality. So it depends on the level of experience, the level of functionality, and complexity of the implementation of the package, and also how long you have, how many times per day you have to spend, you have available to spend on the development. So it's difficult to say.
I think, Damianos, you better touch the one by Nick Sofroniou. Is a C++ one, which is going to be for you to answer.
Yeah, so how are checks for the manual memory management of C++ handled by CRAN, as R has automated memory allocation, in G handling pointers, memory leaks, etc. So I'm not sure I totally understand the question, and I'm not much aware of the answer. Sorry, I don't have the answer for this one.
As far as Zhu Fang question about using code from somebody else's package, a defunct package, as that, I would have thought that from a licensing point of view, everything's so out there, open source, that it's unlikely. I mean, it would be polite to give appropriate attribution, but I don't think would be a problem with actually using that code as the licenses. If something's on CRAN, are invite people to improve on them rather than try and protect intellectual property. Does that make sense to you, Damianos?
Yeah, I think since it is an open source package, you are free to use any of the inside functionality, but of course everyone codes in their own style, so we can adapt the code to our own style, so we can make few changes, adaptations, and it's also great to acknowledge and reference at the bottom of the documentation, or if we are publishing the work in a software journal, acknowledge the use of some already prepared code. So another user says, how well do you feel GitHub is managing the risk of maintainers being pressured or into transferring repository ownership or co-authorship? In the past, this has resulted in some misuse and the introduction of vulnerabilities in certain packages.
My point of view on that one, I think I went into it kind of knowing that the code would be out there, open source, and certainly this, I'm programming statistical tests for non-parametric statistics, so I don't, really come up with having to think about such things. Although, I had a very quick look at the example you mentioned, the link you gave in Wikipedia, and I'm quite glad it wasn't something I didn't have to think about.
Yeah, I did not think of that. So yeah, I don't have a very helpful answer either. But the thing is, we are preparing something open source, so we are prepared of sharing the knowledge, so sharing the code. So I did not think of that in the past. I'll have a look to the Wikipedia link afterwards. So yeah, thanks for the question.
Zufang mentions other repositories. I mean, I don't have any experience of anything apart from CRAN myself. I don't know about you, Damianos, or maybe anyone else who's on the call might have information. If anyone else on the call has used something like Bioconductor or similar, then we'd be happy to hear from them as well. Christina, maybe we're wrapping up then, if that makes sense.
Yes, I will stop recording now. Thank you all for joining.